So, what problems would you guys like to look at today? That could be anything from this review, any of the homework assignments. If you have a problem you just come up with, we can try it. Hopefully it works. Arc length and surface area. Sure, we can do one of those to start. Are you okay with me just doing the one that's on the review? Okay. So let's see. Let's see how this the number 8B, how that goes. Got a marker here. Hopefully one of these works nicely. So the problem is g of x equals square root. Will it be the same way how the last test was, like a flashcard with equations? So you can still have your note card. So what I'm going to do next class during class time, so from 9:30 until 11:30 or so, I'm going to put the test up on Blackboard, and you guys can work the test during that time. And then I would like you to take pictures or scan your test and get it to me by 11:40. So as of right now, there is no one question, but you still may have your note card. And I'll also give you guys an idea of the problems that'll be on there. Alright, so we're told that we're going to rotate this equation about the x-axis. So let me just see if I can scroll to blank screen. There we go. If you would like to print out the test, you may. I would prefer if you did that actually. That way you could write directly on the test. Because I format them such that you can put your answers right in those little boxes at the bottom and so forth. Alright, so surface area. Anybody recall the equation for surface area? Square root of 1 plus, yeah, it involves part of that, yeah. So remember, it's 2 pi f of x square root 1 plus f prime of x squared dx. So we just need to find the derivative of this function. We can talk about that after we're done. Alright, so I need the derivative of this function. So g prime. This is the square root, so I get a 1/2 down in front. Leave the stuff inside alone. And that's to the minus 1/2. But then I got to multiply it by the derivative of the inside. So that's 2 minus 2x. Both of those have a 2 in common. There's a 1/2 out there. I'm going to get rid of all these 2's and simplify. So g prime is 1 minus x over the square root of 2x minus x squared. Everybody okay with that guy? So if not, just go ahead and ask a question. I'm going to go ahead and plug this in to the integral now. So this is going to be 2 pi integral. I need the original function on the outside. Times the square root 1 plus all of this function quantity squared. So it would look like that. So let me go ahead and just erase this because it's kind of in the way. And now if I square this, this guy on the bottom is going to become, the radical is going to be removed. We're going to get 2x minus x squared. Up top, we're going to get 1 minus x quantity squared. So we can go ahead and square that out even. So this is going to be, and actually before I do that, let me just leave it as 1 minus x squared. So I've got 2 radicals. I'm going to multiply this square root by this square root. That means I can take this whole quantity and put it inside here. And it'll become all one big square root. And if I multiply this inside, it would be times 1. So I would get back itself. And then it would be times a fraction that has it in the denominator, so it would cancel, and I would get just this. So then if I square this out and simplify inside the radical, let's see what happens. So I've got 2x minus x squared. This is going to give me plus 1 minus 2x plus x squared. Well, man, that's really nice, because I got 2x minus 2x, and I got minus x squared plus x squared. Looks like I just get square root of 1 at all of that. So this is 2 pi integral square root of 1 dx, and our bounds were from 0.5 to 1.5. So all said and done, this is 2 pi times 1.5 minus 0.5. That's some tough math right there. Hey, look at that. At the end of the day, we all come out with 2 pi. So it looks like Jimmy's really excited. Anybody else? No. So any other questions about this guy? Could we have a problem like that on the test? I don't know. The test is already made. I'll tell you, like I said, when we're done, what the problems will be, or at least what types to expect. All right. So I don't see anybody asking questions about this guy. What other questions would you like me to go over? Can we do number 3? Yeah, as soon as I figure out what number 3 is and can get this board erased, I will be glad to do it for you. And this marker does not want to come off. Bear with me here. So, try one of these Expo wipes, see if that helps. Dang it. There we go. All right. Just so that excess off. So there's that wet surface, it's hard to write on. Okay. So let's go ahead and look at number 3. I see the screen's really Out of focus there. There we go. Number 3, use cylindrical shells to find the volume of a solid generated by revolving the curve bounded. Okay, so I did B for the other section yesterday, so that's already up on YouTube, so I'm going to do A for you guys. So this is y equals x squared, y equals 4 minus x squared, also bounded by x equal y equals 0, rotated about the y-axis. Okay. So again, let me scroll to the clear screen. Okay. So this said it was going to be a cylindrical shell, but let's go ahead and draw the two functions. So x squared, right, we all know looks something like this. And then 4 minus x squared is going to be shifted up 4 units, but then facing downward. So something like that. But then it also says it's bounded by x equal y equals 0, which really means in the first quadrant. So I can forget about everything over here for now. And then I don't need anything beyond where they intersect. Okay, so that piece there. And it says rotated about the y-axis. So I pretty much already had that there. That would look like that. And if I wanted to do a shell, sorry, my picture's a little small here. It would look something like that. Remember that for the volume for cylindrical shells, it's 2 pi integral. I need my radius, which is the distance from the axis of rotation to the slice. In this case, that's just x. And then I need the height of the function. Well, in this case, it's going to be the upper function, which is 4 minus x squared, minus the lower function for my height. So 4 minus x squared, because that's the upper function, minus the lower one, which is x squared. Right, because that will exclude this area that we would pick up and then rotate around. So that's why we do that. And then dx. So the hard part of the problem is really setting this up. The integration here is not hard. And then our bounds we would need to find. Because we went around the y-axis, we have an x equal y equals 0. Our first bound is x equals 0. But we need to find this point when these two equations are equal. So that would be when x squared equals 4 minus x squared. So that's 2x squared equals 4, x squared equals 2, x equals plus and minus root 2. Obviously the plus, because that's the one on the, or in the first quadrant. So this bound would be square root of 2. So this is 2 pi integral from 0 to square root of 2. Inside here we're going to get, if I multiply this all out, this is going to be 4x. This is minus 2x squared times another x. So that's minus 2x cubed dx. Go ahead and integrate. So this is going to be 4x squared over 2, or 2x squared, minus, this is going to become x to the 4th over 4, and so that'll really be x to the 4th over 2, because that 2 up top will simplify it. And then from 0 to square root of 2. And then it's just a matter of plugging these numbers in. So these ones look real easy, so let's do that really quick. So 2 pi 2 times square root of 2 squared, so that's going to be 2, minus square root of 2 to the 4th, that's going to be 4. And then when you plug in 0, everything goes to 0. So you get 4 minus 2, that's 2, 2 times 2 pi, looks like 4 pi. So any questions about that problem? Alright, so what was the next one you guys wanted to do? Can we do the work on a spring? What does the x mean in the volume equation? So this is the radius. Remember that for the cylindrical shell we treat it as though it's a cylinder, right? And so this is R, and let's call this L. Its area is 2 pi RL. So that's where we get the 2 pi. This is R, and this is L. So R could also be affected if we rotate it about some other axis. Jimmy, I know that he said volume, but the volume equation is the integral of the area with respect to x. Alright, so I think I will go ahead and erase this guy and do the spring problem. Wait, you said that... No, sir, that is not the volume. Pi r squared L is the volume. bus does not want to race today. Not sure that keeps defocusing. Alright, where's the spring? Here we go. So this time I think I'm gonna do it this way. All right. So a force of 30 newtons is necessary to maintain a spring stretched from its natural position of 20 to a length of 45. So that's saying our first situation is a spring. We hang 30 newtons from it, and its length is 45 centimeters. It's, let's say, L sub n, its natural length is 20 centimeters. Part A says, what is the length of the spring when 45 newtons is applied? So recall that force equals kx, or k delta x. And remember that that's a magnitude. So first we need to find k using this situation. So we can solve that for k. That's F over delta x. F is 30 newtons. Delta x, well, we went from 20 centimeters to 45 centimeters. So that's 25 centimeters, or 0.25 meters. We got to be careful because newtons has meters inside of it. So we got to convert our units in this case. So is that 120? Yep. And you can leave that as newtons per meter, that's fine. So now if we hang 45 newtons, what's the length? So again, use this equation. Now we're looking for delta x, so that is F divided by K. Now we're applying 45 newtons, and we are doing that with a spring constant of 120 newtons per meter. That is 0.375 meters, or 37.5 centimeters. Now that's the change in length. If they want the actual length, you got to add 20 to it. So 57.5. So that's all part A. We then need to do how much work is necessary to stretch from 45 excuse me, to 50 centimeters. So work is equal to the integral of kx with respect to x where did the last, I think you meant 20 centimeters come from? So this is the change in length. I needed to add it to the natural length, right? What the spring's length is with nothing hanging from it to get the total length when you hang 45 newtons. Alright, so if we use this for our work equation, then we get 1/2 kx squared, and then we have to integrate that from x1 to x2. So this is 1/2 times k, and then my x values are not 45 and 50, but rather their distance from the natural length. So 45 centimeters is 25 away from the natural length. And again, we have to make this 0.25. Just rewrite it. So first, the 50 centimeters, that's 30 centimeters away. And the 45 is 25 away. So this is going to be 0.3 squared minus 0.25 squared. And the reason I have to do 0.3 and 0.25 is, once again, those are in centimeters, and I need to be working in meters. So that's just a unit conversion. And let me calculate that real quick. So I get 1.65 joules. It has to be in meters because the units, so 120, that is K. K is in newtons per meter. This is going to give us meters squared, and a newton meter is the same thing as a joule. So if we didn't convert, we wouldn't get the right units. Any other questions about this problem? Okay. So at least one person responded, so that's good. I'm going to go ahead and erase. Let me take a look and see what 13 is. Give me a second. My hope is to try to not repeat too many problems from what I did yesterday. That way you guys can go back and watch that video if you like, and you'll have twice as many problems done, if that makes sense to you. Alright, so let's look at 13, see what that is. Actually you do not need to worry about 13. I skipped the mixing problems. So you won't need to do that one. So I see why you really wanted to see it, but you don't need it. Alright, so I see Jimmy keeps coming up with problems. Anybody else have another one they'd like to see before I do the orthogonal trajectory? Don't take that the wrong way, Jimmy. I'm just trying to represent everybody here. I would like to do number 6. Okay, so let's see what 6 is first. Okay, I did actually do that one yesterday. If you really want me to, I can do it again. So let's go ahead and just, I guess we'll do the orthogonal trajectory first. And then if you guys really want me to do the tank, we can go back and do that, or if somebody else has another suggestion. Thank you for answering that. Alright, so find the orthogonal trajectory of the family of curves. So remember, the first thing we have to do is find y prime. We can do that implicitly here. So this is going to be 2y dy dx. And then on the other side, we're going to get 3kx squared. So dy dx is 3kx squared over 2y. Now that's the slope of our original. Let's call that m1 for instance. We want the orthogonal trajectory, so that would be the opposite reciprocal of that slope. So the slope of the thing we want is going to be negative 2y over 3kx squared. Before we set that equal to dy dx and do our differential equation, we must replace k. Solving this for k, we get y squared over x cubed. So I'm going to take that and plop it in right there. So this will be, minus 2y over 3x squared. If I take all that away and just leave the 1 over k, 1 over k will equal x cubed over y squared. So I need to take that, multiply it here, and simplify. So I now have, for my slope, minus 2x over 3y. And that's going to equal dy dx. That is the differential equation that I now must solve. That is a separable differential equation. So if I move the 3y over here with the dy by multiplying, and then multiply the dx on that side, I have that. Then I can integrate both sides. So I'm going to get 3y squared over 2 equals minus x squared plus some constant. And then if I solve for y, we would end up with that. Or if you rather, you could leave it as y squared, I suppose. So according to this, it looks like if y equals the square root of a squared term, it should be orthogonal to y equals the square root of a cubed term. Or 3/2 is perpendicular to, effectively, to the 1, it looks like. So you'd have to plot those to see how that all works out for you. Any questions about that problem? Okay. Any of you successfully gone to YouTube and watched any of the videos from the other classes yet? So do you not worry about M1 after you find... So yeah, M1 is just the the slope of the original equation. And M2 is the slope of the equation you're trying to find. So yeah, you don't worry about M1 anymore once you've written M2. Okay. What else did you guys want to see? So far, it looks like we've done 3, 4, 7, and 12. I told you that you could exclude 13. Yesterday, I know that I did the Newton's Law of Cooling problem, which is 14. I also did 10b. I think I did 11b. We also did problem number, so we didn't do 7, we did 8, guys. We did the surface area problem here, part B. We just got done doing this one, number 4, a little bit ago. And we did 3. And yesterday I did 1B and I believe I did not do the disc and washer methods. So I see a request for 9, 5, and 2. So 2 is disc and washer, 5 is cable, and what's the other one? 9? Determine if the proposed solution satisfies the differential equation. Alright, let's do that one real quick because that'll be quick and easy. So determine if the proposed solution satisfies the differential equation. Let's see. Either way, we're stuck doing at most a double prime. I guess let's go ahead and do B, because I'm sure that's the one you guys will dislike the most. So I see y double prime and I see y prime. That means I got to find both of those. So first let's find y prime. So I need to take the derivative of natural log of x divided by x squared. If you really want, you could write it like this and do it as a product. I'm going to go ahead and do it as a quotient, I think. Let's see how it works out. So low d high minus high d low all over low squared. Looks like that. That would simplify to and then you can factor out an x and cancel it with 1 down there, so you'd have 1 minus 2 natural log x all over x cubed for y prime. Then we would need y double prime. So again, low times d high minus high times d low all over low squared. Let's see. Looks like now we've got an x squared in common that we could cancel out down here. So this is -2 minus 3 plus 6 log x all over x to the fourth, or minus 5 plus 6 log x over x to the fourth. That's y double prime. All right. So I've got to plug these into this equation. So I've got x squared times y double prime plus 5x times y prime and then I'm going to have to get rid of these now because I need space. Excuse me just one second. Hey girls, think you can quiet down out here for a little bit? Thank you. Guarantee as soon as I close the window you can start back up. Thanks for the 5-second reprieve. Alright. Plus 4 times y, which was natural log of x over x squared. And we've got to prove this is 0. So this looks to be somewhat of a task. Let's go to town. X squared over x to the fourth, that's x squared in the denominator. So I have minus 5 over x squared plus 6 log x over x squared. This is going to give me, again, over x squared. This is going to be 5 over x squared minus 10 log x over x squared plus 4 log x over x squared. All right, I've got plus 6 plus 4 minus 10, all times natural log over x squared. They cancel. Minus 5x over x, or minus 5 over x squared plus 5 over x squared. Gone. 0 equals 0. Y is a solution. So the derivatives there are kind of difficult, and it certainly doesn't look like it's going to work out nicely for us. But in the end, it does. Thanks, Brentley. I like to think that I do some witchcraft, right? I always talk about math-a-magic. Maybe they should just change the algebra course to witchcraft and wizardry. So any questions about that guy? I guess the only thing you might ask is, where did I get the derivatives from? You can always go back and check out the video for that. I'm going to go ahead and erase this guy. What other problems? 5 and 2. So let's see if we can do one of those guys. So Clement is basically yelling at me on the chat to do number 2, so let me do one of those. All right. So use the disc and or washer, or washer method to compute the volume. I'm just going to go ahead and do the first one. So we've got y equal 2x and we've got y equals x squared rotated about the x-axis. So x squared would look like this, approximately. So clearly we see this is the area bounded, so we don't need any of this stuff. And then it says rotate that about the x-axis. So then we have that. I'm going to cut a little slice here. Cut the same slice down here. Connect them. So it appears that this is going to be a washer because there is a hole in the middle. So remember that we've got to find the area of this disc, or in this case a washer. So it is a circle with a hole cut in it. If we look at it from say looking down the axis here. So I need to take the outer area and subtract the inner area. My volume then, right, so it's a circle, so we have pi integral. We need the radius of the outer function squared. Well, the outer function is the line here. So that's 2x, quantity squared, minus the radius of the inner function, quantity squared, dx. So I'm going to strongly reiterate this one more time for you all. One of the things I notice most often is people will try and take both of these and square it out here. Please, for your sanity and mine, do not do that. Alright, if you can't remember it, always draw your little picture over there and realize that in order to get the area of that circle, or that cutout there, right, if I wanted this area that I've shaded, I have to take the area of the whole circle here minus that one, and the area is pi r squared. So we just need the bounds. They were not given to us in this problem. So to find the bounds, we just need to set these two equations equal. So I need 2x to equal x squared, or x squared minus 2x to equal 0. Factor out an x, and you easily get x could be 0 or 2. And that makes sense. It looks like they clearly meet at 0, and then this point out here would be x equal 2. So the bounds would be 0 to 2. So I can go ahead and integrate. Well, first let's simplify it and then integrate, I suppose. So this is 0 to 2. Inside there I have 4x squared minus this x squared is going to become x to the 4th. Now integrate. So this is going to be 4x cubed over 3 minus x to the 5th over 5, running from 0 to 2. Plug in 2 everywhere. You would then plug in 0 everywhere, but that's all going to go to 0. So this looks like 2 to the 5th pi times 1/3 minus 1/5, or 2/15 in there. So 2 to the 5th pi over, I said 2/15, so that's 2 to the 6th now. And so, just make sure I'm not losing it. It should be, what, 64? So 64 pi over 15. We go with that. Okay. So go ahead and erase this guy. So do you guys feel like you've completely forgotten all this stuff, or do you think you got an okay handle on it so far? I mean, I really don't want to push the test back anymore, so I'm pretty confident we're doing it, but just curious as to how you're feeling. So now you guys see why I didn't want to do the test after spring break. Not just the fact that we can't come back to class, but all right, well, you guys have the whole weekend to prepare. Yeah, I called it coronavirus spring outbreak. Alright, so far I think I've gotten all the questions you asked for. I think somebody asked for 5. Let me see what 5 was. Okay, so that problem is actually really easy. So I'll be glad to do that one for you. So a cable that weighs 275 pounds is 100 feet long. If the cable is to haul a crate that weighs 50 pounds onto a ship that is 100 feet high, looks like it says feel high, I have to change that, how much work is done? As soon as we get done the review, I will explain all of those questions. Alright, so the reason I said this is real easy is because it says 275 pounds. They've already given us the weight. This isn't a problem where they gave us the density. So we don't have to worry about the volume, the area, the length, whatever for that. Or at least for the crate, right? The crate's just weights given. We don't have to figure out the weight due to the density. So the cable's 100 feet. We got a crate. Right, the crate is 50 pounds. The cable is 275 pounds. It has a length of 100 feet. We've got to get onto a ship that's 100 feet high, which means the entire length of the cable has to be picked up and put onto the ship. How much work is done? Well, work is equal to the force times the distance. The force is really the weight. So 50 pounds has to travel 100 feet. And the cable is 275 pounds. But recall that we can use the fact that this is a uniform object, and I can model it with a center of mass, which would be half the distance. So remember all the problems we did before, they gave us the density of the cable or chain or whatever. So we had to multiply it by its whole length to get its weight, and then half the length to get the distance that it travels. But in this case, we don't need all that. So we just need 50 times 100 and 275 times 50. That is 18,750, and that is foot-pounds. So I know the differential equations are the most fresh in your mind. Would you like to do any of those? My guess is that maybe we'll finish a little early. You guys don't seem to have a ton more questions, or at least haven't posed them yet. So any questions about this guy? Okay. Would you rather a integrating factor or the separation of variable? Technically, the orthogonal trajectory that we did earlier was separation of variables. So maybe it's better if we do an integrating factor. How about we do 11a? Come on, mouse. All right. So 11a, I've got y prime minus 2y equals 3e to the 2x. And y of 0 equals 0. So recall that for integrating factor, we've got to be in this format. dy dx plus p of x y equals some q of x. So from that form, we can decide what is p of x. So we're already in that form. That means p of x here is -2. And our integrating factor is e to the integral of -2 dx, or e to the minus 2x. The next step is to take the integrating factor, multiply it by the equation in the correct form. So this is e to the minus 2x y prime minus 2, I'm going to write e to the minus 2x here, times y equals 3. And now if I do e to the 2x times e to the minus 2x, that's e to the 0, or 1. So if you want, I can write that out here. All right. So then this side here, we've stated that this should always collapse to d dx, or whatever the particular variables are, of y times the integrating factor, so e to the minus 2x. And so let's prove that. Derivative of y with respect to x, that's y prime. Leave e alone. That's your first term. Then take derivative of e to the minus 2x. That minus 2 comes down in front. So you get minus 2 e to the minus 2x. You leave the y alone. That all looks good. And then over here we just have equals 3. So the last thing I need to do is take this dx over here, integrate both sides, and solve for y. Okay. So integral of the differential, I'm just going to get back what's inside those brackets. I'm going to come over here now. So I have y e to the minus 2x equals 3x plus c. And then if I want y by itself, just divide by e to the minus 2x, or multiply by e to the positive 2x. Now I want to find c, so I plug in 0, 0 here. And guess what? We get c is 0. Is it worth factoring out the e to the 2x out of the general equation? You certainly can. By worth, do you mean the correct way, or are you going to get more credit, that sort of thing? I don't know what you're searching for there. Or you could write it that way, and you'd still come up with the same constant c. So if c is 0, that means this term right here disappears. Y is this in order to pass through that point. Yeah, there's really no additional benefit for doing it that way. I mean, the only other thing is you don't have to plug 0 in more. If it was a different number, maybe it'd be better, because you could then just divide over and solve for C. Any other questions about that problem? Okay. So any other problems you would like me to work out? Okay, thank you for answering. Anyone else want to see any other problems? Thanks for the all caps. Guess you're yelling at me? Right, well, if the majority of you do not need to see any more problems, then I will go ahead and stop this recording, and I will upload it to YouTube. And everyone stay here, and I will go ahead and we can talk about the exam, what the problems will be, that sort of thing. So I'm going to stop recording. I'll leave up the stream for a few minutes so we can chat.